welcome to True Projects. In this video, we are going to explain about the project that is cotton yield prediction, a machine learning approach with field and synthetic data. So, before getting into the execution, first let us understand what is the project about. Think about how important it is to know in advance how much crop will be produced. Farmers rely on this information to plan their finances, decide on fertilizers, and also manage their resources efficiently. Policymakers and also businesses, they also need these predictions to ensure food supply remains stable and prices don't fluctuate widely. But here, but predicting crop yield isn't straightforward. There are so many factors involved. That is weather conditions, soil type, crop variety, farming methods, and even unexpected events like droughts or pests. These factors don't work in isolation. They interact in ways that make it challenging to predict yields accurately. And now imagine what happens if predictions are off. If yields are overestimated, there could be excess supply, leading to wasted resources and also financial losses for farmers. If underestimated, food shortages can occur, driving up prices and also affecting millions of people. So that's why having a reliable crop yield prediction system is so important. It allows for better decision making at every level, from individual farmers to national policies. With accurate forecasts, farmers can adjust their strategies, government can plan their food distribution, resources can be used more efficiently, and also everything can be done very smoothly. But we do have some traditional methods. So we do have some traditional crop yield prediction methods that are based on agronomic principles and weather data. These models try to simulate how crops grow under different conditions, but they require a lot of fine tuning and massive computational power to work well. Plus, with climate change causing unpredictable weather shifts, these traditional models struggle to keep up. So, this is where machine learning and deep learning comes in. Instead of relying on rigid formulas, these models learn from huge data sets and also identify patterns that might not be obvious. They can handle complex non-linear relationships, meaning they can adapt to real-world conditions much better. So this approach it just doesn't improve yield forecasting. It also helps farmers to make smarter decisions, reduce resource waste, and also contribute to sustainable agriculture in a rapidly changing climate. And this project is designed to predict the cotton yield using machine learning. So instead of relying on some other techniques, some other traditional methods, here we are using machine learning models to predict the cotton yield by using field data and also synthetic data. And here we have leveraged several machine learning models that are random forest, support vector regressor, light GBM, and neural networks. So these models will be trained on the field and synthetic data and they will be used for predicting the cotton yield. And here we will be doing prediction as reliable possible by considering several key factors such as soil quality and how much nitrogen fertilizer is used, phosphate is used, etc. All of these play a crucial role in how well the cotton grows. So including them makes the model more precise. And to check how well these models perform, we are incorporating several key metrics that are RMSE, that is root mean squared error, R square, MSC, that is mean squared error, MAE, that is mean absolute error. So these are basically different ways to measure accuracy and errors. The system offers a fast, reliable, and computationally efficient way to predict the cotton yield, helping farmers and decision makers to plan better for things like resource allocation, harvesting schedules, and also overall crop management. And to further improve the performance, here we have incorporated voting regression model, which is an ensemble model. Now, instead of relying on just one machine learning model, this model combines multiple models and takes their collective predictions to come up with a final result. And the idea here is that blending different models, the system becomes more reliable and accurate as it balances out the weaknesses of individual models and captures more patterns in the data. And here we have developed front end using Flask framework. So here we have developed front end using Flask framework. This makes it easy for users to input agricultural details like soil type, fertilizer, etc., instantly getting the yield predictions. So instead of running complicated code, this will help users to get a simple interactive way to access them. And to make it secure, user authentication is also added. This means that only authorized users can access the system, ensuring that the data and predictions are protected. So overall, combination of advanced machine learning and user-friendly interface makes the system both efficient and accessible for farmers, researchers, and also policymakers. So this is all about the extension. Now, To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary Python libraries that are pandas, numpy, matplotlib, seaborn, scikit-learn, flask. And coming to exploring the dataset part, so here before jumping it into modeling, it is important to understand the dataset. So here we understand Cottoneel dataset, we load it and we analyze to check the number of rows, columns, data types of each column, missing values, and summary statistics. Then comes data processing. So this step involves cleaning and preparing the data, which is important for machine learning model to understand the data. So it includes handling missing or incorrect values, converting categorical data into numerical format, normalizing and scaling the data. Coming to data visualization. So here graphs and charts are created to understand patterns in the data. For example, histograms are drawn to see the data distribution, and we have also drawn scatter plots, correlation, heat maps, etc. Then comes selecting X and Y data. So here the data set is divided into X and Y. X contains input features. So these are the factors that cotton yield, like temperature, soil type, and all the factors include. And Y is a target variable. This is the actual yield value that we want to predict. Then comes the feature selection part. So here, not all features in the dataset are equally important for predicting cotton yield. Some might have strong impact, while others might add noise and reduce model performance. So to select the best features, select percentile from scikit-learn is used. This method ranks all the features based on their importance and selects only the top ones, helping to remove less relevant features, improve model accuracy, reduce computation time. And then we split the data into training and testing sets. So training set is used to train the model, and testing set is used to evaluate the model performance on unseen data. Then comes building the model. So here we will be training, different machine learning models like random forest, support vector regressor, light GBM, neural networks are initiated. They are defined in this step. In the next step, that is training and building the model. So here each model is trained on the data set, and the model learns from the past yield data to find patterns that can help to predict the future yields, that is cotton yields. And then we evaluate all the models using this MSE, RMSE, and MAE. MSE is mean squared error, which measures the average square difference between actual and predicted values. Then comes RMSE, that is root mean squared error. This is similar to MSE but takes the square root to get an error in the same unit as the target variable. And coming to MAE, that is mean absolute error, it measures the average absolute difference between actual and predicted values. And we compare all of them through the graphs. And a web interface is created using Flask that allows users to interact with the model easily. And here features include registration and login, where users can create accounts and login securely. And SQLite database stores user credentials and the data. And here in the front end, users will be able to provide inputs as feature values, and that will be pre-processed at the back end. It will be trained, it will be fed with a trained model. Finally, trained model will be predicting the cotton yield. So this is how we have implemented. Now moving on to the algorithms used. So these are the algorithms used in this project. So here we have used linear regression, random forest, light GBM regressor, MLR, support vector regressor, and this is the extension model voting regressor, which combines boosted decision tree and the extra tree. And to implement this project, we need hardware and software requirements. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we are supposed to open the code folder that contains source code files. So let's open the code folder. These are the source code files in the code folder of the project. Let us understand each of them. So in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in this folder, that is templates folder, we have HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating content to be rendered in HTML templates. And this is the main dataset that is used in this project. So this is the dataset that we have used. And here from all these features, we will be selecting the most important features that impact the crop yield. So close this. And here in this model.sav file, we have the algorithm information that is stored and that will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases that we will be using in the front end for predicting the cotton yield. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, and now click on enter. Here you can observe, right, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will compile Python script. This command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. And this is the web page of the project, which is displayed in the browser. This is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? So these are the input parameters need to be given. So based on the given parameters, we will be getting the prediction. That is the cotton yield will be predicted. So let's understand what are these parameters first. First, we have cotton area. So it is a total area in 1,000 hectares where cotton is cultivated. Then we have cotton production in tons. That is 1,000 tons. So the total cotton production in 1,000 tons from the cultivated area. Then we have May normal rainfall millimeters. So it is the average rainfall in millimeters recorded in May over past years. And then we have October normal rainfall. So it is average rainfall in the October. Similarly, we have for the month of November, we have for the December, January, August, June, and here we have for annual normal rainfall. So here this refers to the total average annual rainfall in millimeters received. And then we have February months, March months rainfall. So this is all about the parameters. Now let's enter them. For that, let's open the test cases in the code folder. So let's open the sample file. Here it is open. So these are the cases that we are supposed to give as input. So here we have multiple cases. Let's get back to the application. And here let's try with the first case where cotton area in 1,000 hectares it is 17 and production in 1,000 tons it is 4,000 tons and May month rainfall is 12 and October month rainfall is 119, November is 16, December is 9, January is 40, and then we have 137 in the August month, 60 in the month of June, and annually it is 423, and in the month of February it is 11, and in the month of March it is 7. Now click on predict. So here the given input, it will be pre-processed at the backend and then it will be fed to the train model. Train model will be giving us a prediction. So here we got the prediction of cotton yield per kg, hectare. So here, so in total 1 hectare, 1878 kgs will be produced. So it is per hectare. Now let's check with the other case. So now let's check with this case. So here, the cotton area in 1,000 hectares it is 177, that is 17,730, and production is 1,990. May month rainfall is 12, 17 is the October month, November is 3, December 14, January 36, And then we have 69 as August, June is 50, 300 is annual rainfall, 15 is February month, and then 9 is the March month. Now click on predict. So here we got the prediction. So here for the given case, when the situation, I mean, when the crop yield will be in all these conditions, I mean, when the rainfall is in this condition, here it will be predicted as 1378 per hectare. It will be 1378 per hectare. That many cases. Now let's check with the other case. So now let's check with this case. So here cotton area per hectare it is 536, that is 536. Then we have 849, that is 849 tons per kg. And then we have May month rainfall, that is 7.457, and October month it is 134. November it is 4.785, and December month it is 2.117. January month is 22.2, and then we have 19.4 in the month of June. Sorry, we have entered it wrongly. Let's recheck again. So here in the month of May it is 7.457, in October it is 134, and then in the month of November it is 4.75, and here in the month of December it is 2.117, and here in the month of January it is 2.22.2, and here in the August month it is 96.75. And then in the June month it is 19.4. Annual normal rainfall it is 219.9. And then in the month of February we have 2.678, and then we have 3.328. And now click on predict. So here we got the prediction that the cotton yield predicted for that particular hectare it is 1723 per kg, hectare per kg. So these many kgs it will be produced. Now let's check with the other case. So now let's check with this case where cotton area, that is for 1000 hectares it is 10, and then we have 1000 tons it is 13. May month rainfall is 9.83, 134.2, that is October month. 5.516 is the November month, and December month it is 2.797, and January month it is 21.92, and we have August month that is 21 point. So here for August month we have 87.9, and then we have 19.4 for June, and then we have annual it is 219.9. February it is 2.82. March it is 2.39. Now let's click on predict. So here we got the prediction. So here we got the prediction that cotton yield predicted as 1963 kgs will be yielded for that particular area, that particular crop. So now let's check with the graphs. Click on graph. So here the first graph which we have is the correlation matrix graph. This is the correlation matrix graph which shows the correlation between variables. And this is the R2 score graph. Here on x-axis we have R2 score, and on y-axis we have all the algorithms that are trained. And this is the MSE, RMSE, and MAE. So these are the graphs of the project. Now click on sign out. In this way, just by entering the values to the application will predict the cotton yield. This is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.